Here we get a confidence score of 0.81. We're detecting the mock. Again, we're detecting the mock. We're drawing like really nice bounding boxes around the mock, and they act like really close to the ones I drew in roboflow. Hey guys, and welcome to a new video in this neural networks and deep learning tutorial. In this video here, we're actually going to create a small project where we're using the YOLOv5 neural network, where we're going to create a custom object detector. So we're going to do everything from scratch here. It's actually like really easy to set up. I'll provide the Colab notebook, so you can actually just go to my GitHub link in the description. Go get the code, train your own custom object detector. I'm going to show you from scratch how we can actually generate a data set, how we can annotate and label the data set, drawing bounding boxes and so on, how we can load in the data set into Google Colab and then train our YOLOv5 neural network to do object or like custom object detection. But first of all, remember to join Discord server. I'll link to it down in the description here. You can join the channel, chats about computer vision, deep learning, AI, and so on. You can also become a member of the channel if you want to support the channel with a small monthly fee. Everything will go to create more and better quality content here on the channel. Also, if you have some problems in your own projects or applications, you can also become a member of the channel and I can help you out and guide you in the right direction. So thank you guys. So first of all, here we're just going to start in the YOLOv5 GitHub repository here from Ultralytics. So here we can see the nearest model here of YOLOv5. We can get a short description of like what is going on, some documentation, how to set it up, and what different kind of like libraries and frameworks can we use it with. So here we can just see that the YOLOv5 is a family of object detection architectures and models pre-trained on the Coco dataset, and then we can actually use transfer learning to train it on our own objects and so on. There's a lot of different kind of variations of the YOLOv5 models. We can use some like small models, large models, depending on your application and also the complexity of your objects that you want to detect in your images. We can see how to install it here. We can just like pip install it from the requirements here from GitHub. We can see Inference here, how we can actually like implement and deploy the models that we have trained our YOLOv5 model on, both with OpenCV, NumPy, Pill, and so on. So basically we can just load in our model by using PyTorch, and then we can just have our images. Then we can just call model and then pass in the image into that model, and this will actually like be the result. And then we can just print the results. We'll get the bounding box of the objects that is tracked or like detected in the image. So in another video, I'm going to create another video where we're going to create a project. We're going to load the model into OpenCV so we can actually like do live object detection where we're tracking around objects from our YOLO model around in the image frame. So also just to show you how we can actually implement and deploy this in our own projects and applications after we trained it on our custom data set. We see there's a lot of different kinds of tutorials here on the GitHub as well, both for inference training, but also some tutorials here how to train a custom data set, as I'm going to show you throughout this video. We can see tips for best training results, weight and bias locking, how we can actually lock those during the training of our neural network. We also have some multi-GPU training, roboflow for dataset labeling and active learning, as I'm going to show you as well. So we're going to use roboflow to actually like upload our dataset too, so we can then label it and annotate our data, so we can actually like draw bounding boxes around all the objects that we want to detect in the image frame. So then we're going to generate our dataset with roboflow. We're going to load it into Google Colab, train our actual like YOLO model here on the GPUs from Google Colab, and then we can actually export those models after we have done like validation and also seen the results of our object detector. We can also use transfer learning with frozen layers, some hyperparameter evolution, and so on. We can see the different kind of environments. We can see Google Colab, Kaggle, and so on, integrations. So, and then we can also see all the different kind of models down here. So we both have like different types of YOLO models if you want better performance, or if you just want to have it to run faster. So there's a trade-off between like accuracy and also the speed. So you need to choose the model that fits best for you. Down here we can see the metrics for all the different kind of pre-trained models here. In this video we're going to use YOLOv5 and the small model. We can see the pixel size that it takes as input, and also all these different kind of metrics here, both the speed and also the accuracy and the number of parameters and so on here. So we can test out different kind of models depending on your application and also how complex your application or project or objects are. Also, if you want to detect multiple objects in your image compared to only like one object. In this video here, we're going to detect a mock, so we will only detect one object in the image frame, but you can just have multiple objects. You just need to label them with roboflow, as I'm going to show you. So So now we're jumping straight into RoboFlow here. You can just go in, sign up, and get like a free trial. Then we can use this mock detector. I already created a project for that. Then we can go into the overview here, see some different kind of things, and also the upload. So we can upload images, new images from our dataset. We can go in, annotate them as well. We can see here that I've already annotated or labeled all these images. We can then split it into a validation and training set and also a test set. But if we just go into one image here, for example, we can see that I have drawn this boundary box here around here the cup. When you go in here, you can actually just change it. We can just go in here, for example, and then we can generate the tool. Then you just get this tool up here and you can actually just draw a boundary box here around it. Then you get up some couple of different kind of like options up here. So you can just save this class. So in this example, I just called it mock. And then when we hit enter, it will just create this class here called mock. If you had multiple objects in the image frame, for example, if I wanted a person too, so we can create a new class called face. And then when I hit enter, we will just create this face class here as well. And then it will just do all the stuff for us. It will generate the different kind of files that is needed, like the format files needed to actually like train the YOLO model. But this video here, we're just going to take the mocks. I already did the annotation on all the images here, so we can just go through them. We can see the boundary boxes here that are drawn around this mock that we want to detect on. So here we just have 70 images in our test set. So this is actually like fairly good. We'll get some really nice results only with 70 images. You can also generate more, but this is just to show you guys how we can actually get started with creating a custom object detector with YOLOv5. So after we have actually like uploaded our images and annotated them, we can go into our dataset and then we can just generate a new version of our dataset. I've already created one here, but now we're just going to create another one just so I can show you how we can actually like do it. First of all, we just need to choose like the train and the test split. So in this example, you can just go up here and rebalance it. So right now we're just choosing like 20% for validation and all the other images. We want to use that for training because we don't really have that many images in our dataset, and we're not going to use anything for test because when we're going to test it, we're just going to use our validation images. But if you had like several hundred images, you can split it into another, like, so you have like actually have more validation data and also test data and so on. But in this video here, we're just going to go with 70 train images and 8 validation images. And even though we have this low amount of number of images in our training set, we will still get a really nice object detector, as you're going to see. So here we're just going to hit save. So this is our train test split. Then we go down here to the pre-processing, and we can actually to choose some different kind of pre-processing step. So right now it just automatically do auto orientation and also resizes it. So resizes the images to 416 by 416. So it actually this is just input size to the YOLO model that we need to. We can also add some other different kind of like pre-processing options if you want to do that in your image. For example, we could grayscale all the images before we're training our neural network to make it faster and also to reduce the complexity a bit. If you're, for example, right now we have this mock here which is yellow, so we might benefit from having actual like RGB images compared to grayscale images when we're going to do this object detection, at least when we have this low amount and number of images. So after we've done the pre-processing, we can go down and choose some different kind of augmentation steps. You can just go in here, choose, for example, we want to do horizontal flip, or if you want to do vertical flip in some way. It doesn't really make sense in this example because we don't want the mock to be on the upside down. So in this example, we're just going to use flip as a data augmentation method. And also the rotation here, we can choose the angle here that we want to rotate our images on here as well in our actual augmentation. And it's really important that you use augmentation if you have a low number of images. In this example, we only have 70. But as you're going to see, we're going to get a lot more images when we're actually using augmentation, and we will also get more variation in our images that we're going to train our neural network on. Just to show you some other different kind of augmentation options we have, we can also rotate our images 90 degrees. We can crop them if we want to crop our images, or zoom in and out if we want to have our models generalizing more on that. If it really doesn't matter where the object is in the image frame, in the depth, for example, we can use crop. We can also shear, grayscale it. We can play around with some of the different color spaces. We can flip it, crop it, and so on. So we can do a lot of different kind of things. We can also apply blur and noise on the images if we want to have a more robust solution, or a more robust neural network when we're actually training on neural network. So here we're just going to hit continue. We're going to go with flip horizontally, and also we're going to rotate it between minus 30 degrees and plus 30 degrees on our images. So now we can just go down. The last step is to generate our actual like data set. We need to choose the maximum version size here. So again, for the free version, you can get up to like 3x the number of images that you actually like have when you're applying data augmentation. If you had some other different kind of plans, you can see you can get a lot more images here from using data augmentation. But right now we're going from 78 images up here from the source images to 218 images after we have actually applied data augmentation on our images, so we create a more robust and general model. So now we're just going to hit generate, and it will actually like generate our whole data set. We can just go up here, call it mock dataset 2. We're going to save the name. It just processes and generates the images here. So again, right now it took like 5 seconds to generate the whole data set here with the data augmentation and so on. We can also see all the different kind of images that we have, the 216. These images is actually like flipped, and we can also see here that we have these images that is rotated. So right now we have all our images in our data set. We have 208 images in our train set. We have 8 images in our validation set. So this is not really that many images in our validation set, but as we're going to see when we're going to test it, we're still able to detect the mocks in our actual like images, even though we have this only 280 images that we're training on. But right now we can actually like both train here in model here, but it actually like costs money. But we can just go into Google Colab. I can show you how we can train a custom YOLO model with this dataset here from RoboFlow. So right now we have our dataset generated. Then we can just go in here and export it. So now when we export here, we can just go into show download code here. We're just going to choose the format, and in this format, when we actually like training YOLOv5, we need this YOLOv5 PyTorch TXT format. Also, if you're using some datasets from the internet or like from Google and so on, and you have just downloaded to your computer, make sure you know like what format it is on. You can actually like convert it here in RoboFlow as well. If you just upload the dataset, you can, for example, convert from Pascal VOC format to YOLOv5 PyTorch text format, so you can actually train your custom YOLOv5 model. You can both download the dataset to your computer in a zip file, or you can just show the download code that we can then directly get in Google Colab and download into our notebook. So here we're just going to show the download code. When I hit continue, it will just start with start out with zipping the files, and then it will download them. Then we just get this code snippet here. We can just copy this. We will get an API here that is just like a private API key here. So it just goes in, gets the data sets from RoboFlow here, and then we can actually like store our data set in this variable in our code. So this is all we have to do in RoboFlow. We have downloaded the code, and now we have this code snippet that we're just going to copy paste. And then we're going to copy it, and then we're going to paste it into Google Colab. So now we're jumped into Google Colab, and now we're going to do the whole like update detection, custom update detection with the mock. So we started from scratch. We generated the images on our computer, and then we just used RoboFlow to do annotation, label the images with all the bounding boxes. We did some data augmentation, generated a data set, and now we have copied the code snippet, so we can like download our data set into Google Colab. As we can see here, we have no files in the directory right now, but when we actually like download both YOLOv5 and also the dataset, we will get all of these things over here in our folders. So right now we're just going to set it up. First of all, we're just going to clone the GitHub or like clone the repository YOLOv5, as I just showed you on the GitHub repository. So we're going to clone that. We're going to install the requirements. So these are just the code snippets from the GitHub tutorial from YOLOv5. Then we're going to import Torch, OS, and also IPython display, so we can then display the images later on with the actual like update detection of the mock. If we're actually able to use CUDA here, we're going to use the CUDA device or like a GPU to actually like train our custom YOLOv5 model. You need to make sure you go up to runtime, change runtime type, and then you need to choose the hardware accelerator here as the GPU. Then it will train the model on the GPU, and it will take it will just go way faster than using the CPU. You wouldn't be able to train your custom YOLOv5 model on a CPU. So just use the GPU here in Google Colab. So we're going to run this blob code. We will download YOLOv5. We're just cloning the repository. And then when we go into the files over here to the left, we can see we actually like get this YOLOv5 repository. We see both the data, the models, some requirements that we're going to download, how a training script, a validation script, and so on. And also to get up some setup detection, so we can actually like do detections with just a Python script. We just call it with some different kind of like arguments to that Python script. So now we're just going to go in here, go to the next block of code. So now we're just going to open up like the roboflow here. So we're going to create our roboflow. We're going to use the model format, which is YOLOv5. So this is just the format that we stored our dataset in. And also the notebook here will just be Ultralytics. We're going to run this block of code after we've completed the first one. And now up here we can see that the setup is complete. We're using towards 1.10.0 plus CUDA here 11.1. We also get the information about what GPU are we actually like training on. So now we're going to set our environment here to the dataset directory. So we'll just be content/datasets. So this will just be the folders that we have over here to the left. So we're going to set our environment up, and then we can actually like just go down here and paste in our code snippet that we got from roboflow. We already installed roboflow and we have also already imported it. So we're just going to delete those lines of code. This will be the private API key. You can also just use it if you want to use the exact same detector or like the mock detector as I did. If you don't want to generate your data set beforehand and you just want to test this mock detector here on your own images and so on. So then we're just going to set up the project, and then we're just going to take the data set here. So we need to choose the version, and the version here that we're going to use is 1. So this is the first version of our mock detector, because I already had one, which will be version 0. So I already had one, but we created a new one that we're going to train on. So now we're just going to hit enter, or like we're just going to run the flow of code. We can see that we're loading the robo workspace, we're loading the robo project, then we're downloading the dataset here in the zip file into content/datasets/mock detector 1 to YOLOv5 PyTorch here. We can also see the progress bar. So now we have actually like downloaded, and we also extracted our dataset. So if we go over to the folder to the left, we can now see that we get our datasets folder up here to in the top. We can see we get mock detector 1. We can go down here, we can get all the training images, all the images, and also all the corresponding labels with the bounding boxes inside of that. We also have our validation images, so these will just be the exact same ones, but in the validation we only have 8 images to show. If I'm going to open this one, we can just see the images that we actually have that we're going to do validation on. But this is all we need. We also get all the labels here. If we just go down, we can just take the validation labels. So if we go in here and open this file, we'll just get the bounding box that we have actually like annotated in roboflow as I showed you. So we're going to close the folders here again. So now we have our dataset. Now we can just go in and train the YOLO model with this training Python script that is provided by YOLO as well on the GitHub, and that we cloned into the repository. So we're just going to run this Python training script. Then we're going to set the image dimensions, the batch size that we want to use, the number of epoch that we actually want to train our model on for, and then we need to specify the location of our actual like data set. So this will be dataset.location/data.yaml. So this will just be, this will actually just be the directory for the labels of our data set and also the images. Then we need to choose the weights. So in this video, we're just going to use YOLOv5s. So this was the small model that we're going to use. There's a smaller model, one smaller model, but in this video, we're just going to use the small one. We just have the PT here, and then we need to specify cache because we just want to cache the images in the GPU when we're training to actually like speed up the process when we're training it and also benefit from it when we're running 100 epochs. So right now we're just going to run the script or like run this block of code. It will just train the whole YOLO model here. So again, we can see that it's just downloading some different kind of stuff. It sets up the hyperparameters with the learning rate, momentum, weight decay, warm-up epochs, and so on, and also all the other different kind of things. It will download the weights, the biases, and then it will actually train the YOLO model. So now we can see down here that it has downloaded and it has now started training the neural network. So first of all, we just get a summary here of the model. So this will just be all the convolutional layers in the actual like YOLOv5 small model, as we can see. So we can go in, get the exact dimensions of what is going on, all the layers. We have some convolutional layers, some upsampling layers, some concatenation layers, and so on. But if we go down to the bottom here, we actually get all the epochs that we're running. So now the training here has actually started, and we just get out this information about the GPU memory that we're using, some of the different kind of like object boxes, the classes, the number of labels, the image size, and also the precision over here to the right. So these values here, 0.5 and 0.95, is the confidence scores of the bounding boxes that we're actually like predicting on our images. So these values here should actually like increase over the number of epochs. We can also see that it actually like takes around like 7 seconds to run through each of the epochs. So it doesn't really take that long time when we're using the GPU to train a YOLO custom optic detector on a data set that we just created by ourselves, and we actually like will end up with some really nice results. So this just takes a couple of minutes to train the neural network here, and then we can just do predictions on it later on. So now your custom YOLOv5 model here is actually like done training. We can see that 100 epochs here completed in 0.23 hours. We can see that the optimized script here for both the last weights and also the best weights. So we can actually go in here, and then it is validating the best weights that it found during training. We're also going to see the training results down here in a second, but we can see we get a model somewhere here of 213 layers. We can see all the different kind of parameters and so on, the images, labels, and so on. So we can see the results are saved to runs /train/experience. So if we go in here, we can actually go into our YOLOv5, then runs, train, and then into our experience, and then we just get all the weights here actually. So we both get the best model and also the last model during our training. So when we're going to do inference and do predictions on new images, we're just going to use the best model that it found during training. We can also get some other different kind of information about the results, training badges, validation badges, some labels, confusion matrix, so we can actually see the results. But here we're just going to go out of the folders here again, and then we're going to use TensorBot to actually like lock the different kind of metrics and values that we had during training. So here we're just going to load in TensorBot, and then we're just going into locked here and then runs. So we're just going to display and show all the training results that we got during training of our YOLOv5 custom optic detector. So here we're just going to run this block of code. It will then launch TensorBot, and then we'll get all the different kind of metrics and graphs up here of our training results. So as we can see here, it is loading up. We get all the different kind of metrics. I'll just zoom out here a bit so we can see what is going on. So this is all the metrics that we got from the experience. Down here, it will just be the first training. So we see we start at epoch 0, and then we go all the way up to 100 epochs, and then we can see the results over time. So we can actually see here for the precision, or like this metric MAP, with a confidence score of 0.5, we actually have a really nice convergence here at the end where we get a value of 0.99.5. So we have a really high accuracy on this metric here. We can also see for the confidence score of 95% confidence here, that it is actually like a bit more fluctuating here in the training process, but we can also see that we get a really nice result. We end up with values of 0.80 in the precision. We can also see the precision over here. It also converges towards 1 at the end here after around 50 epochs. It is the same with this metric over here to the left, MAP. We can also see it converges after maybe 40, 50 epochs, and the same down here with the recall matrix. We can also see these results. So these are just the training results that we got from training our actual neural network, and it only took like 10 minutes, 15 minutes to actually train this whole neural network here on our custom data set. You can do all of it yourself and so on, and use the GPU here in Google Colab. Everything will be down in the description. I'll link to my GitHub. You can go get all the things and also the data set from roboflow. So now here we can also see the box loss here. It keeps decreasing. Our loss function here is actually just constant, and our optic loss also just decreases over the number of epochs. So the losses here, we want to get them as small as possible. As we can see here, it actually like still decreases a bit after 100 epochs. We could maybe like run it for 120, 150 epochs, but again, we're still at a very, very low loss, so it wouldn't really matter that much. And it's also just the box loss, so it would just be the precision of the bounding box that we're drawing around the object, and not really like if we can detect the object or not. So down here, we're now going to do predictions. Again, we have a prediction script provided by YOLO. So here we're just going to run this detection Python script. We set the weights of the neural network or the model that we want to run the predictions on. So again, we just go into our train, runs, trains, experience, weights, and then we're just going to choose the best weights from our whole training process of 100 epochs. We're going to set the image dimensions and also the confidence score. So If we actually have a confidence score that is over 0.1, so if there's a more than 10% chance that this is actually like a mock, then we're going to say that this is actually like a correct prediction, and then we're going to display it. We can play with around with this confidence score here. We can set it to 20%, 30%, 50%, and so on. But right now we're just going to maybe go with 0.2, and then we're just going to choose the source here of our images that we want to do predictions on. And again, we don't have any test images, so we're just going to run our predictions on our validation images. Then down here, we're just going to have this for loop where we're just running through all the images in our actual like detections. So first of all, we just run this block of code. It will do the detection on all the images that we have in our validation data set. So again, we had around like 8 images, as we can see here. So now we have done the prediction on all those images, and then we can actually like go down here and display them. So right now we just only have 8 images. We can see the results are stored to runs /detect /experience, and also the speed here and so on. So we get all the information here, how long it took to process each of the individual images, and also how many mocks did we actually like detect in the image frame. So we can see here that in all the images we were able to detect 1 mock. If we had maybe 2 mocks in the image, it will probably like return 2 here, and it will draw perfectly bounding boxes, like perfect bounding boxes around those mocks as well. We can test that when we're actually going to deploy the neural network. So make sure you hit the subscribe button and also the bell notification, so you will get a notification when I upload a new video where we're actually like deploying these YOLO models here with OpenCV. We're opening up the webcam, moving the mock here around in the image frame, trying to track it around in the image frame, and also maybe have multiple mocks, so we can actually see, okay, we have only trained our neural network on images with 1 mock. Is it actually able and capable of detecting multiple mocks in an image, and how reliable and robust is the solution? Even though we only have 200 images, or like we started out with 70 images, we augmented the images, so we now have 200. Then we trained a model here for 15 minutes. So it took like 20-30 minutes in total, and then we actually have a custom object detector that we can then use to deploy in our own projects and applications. But now we have run all the predictions here. We've saved the results. So now we can actually like just go down here and go into content, YOLOv5, then runs, detect, experience, and then we're just going to take all the JPEG files inside of this folder, and then we're just going to run through and display them with the corresponding bounding boxes. So now we're just going to run this block of code, and it will then display all the images here in our validation set. I'll just scroll up to the top. So now here we can actually see it detects a mock up here to the right. We can't really see the confidence score here because it's out of the image frame. But here we're actually detecting this mock, even though we can only see this mock here because my hand is kind of blocking the mock here in the image. But we still get a confidence score of 70% in this image here. So it's actually like a really nice object detector that we created, but only having 70 images. So this is really efficient and really robust neural network and model that we can use. Here we get a confidence score of 0.81. We're detecting the mock. Again, we're detecting the mock. We're drawing like really nice bounding boxes around the mock, and they act like really close to the ones I drew in roboflow, where I act like annotated and labeled the images with the bounding boxes here as I showed you. Again, we can see we're able to detect the mock in all the images here, but we get a lower confidence score if we can't see the whole cup or like the whole mock, as we can see up here in this image. So here we will have a lower confidence score than compared to, like, for example, if we can see the whole mock in the image. But again, we're going to save the model here, as we can see here. So we can go in, runs, train, experience, weights, best. We're just going to take the best model, and then we're just going to download it into Google Colab. We can then download it from Google, or like from Google Drive here, from our files, and then we can just deploy them in our own Python script with OpenCV or some other different kind of frameworks or libraries for loading in like NumPy arrays, and then just displaying them with a live webcam, for example. So we're going to do that in another model, in another video. So we're just going to save the model here. We can see that we're downloading the best model. It will download it to your computer. We can just download it, and then we can import it later on in our own Python script. So that's it for this video here, guys. We've been through how we can actually like generate a data set, label the data set with the different kind of bounding boxes, how we can import that data set into Google Colab, get a custom or like get a YOLOv5 model, train the YOLOv5 model on our data set, and then do predictions on new data that it hasn't seen before. So it took 20-30 minutes. We created a custom object detector. You can use arbitrary objects. You can have multiple objects in your image frame. Like you can actually have just 100 objects that you want to track in the image frame. You just need to label all the objects that you actually want to detect, and then you need to train your model on that. So it's really nice, it's really cool, and we're going to create some really nice applications and projects with it on this channel here in the future. So again, make sure to hit the subscribe button and bell notification under the video, and also like this video here if you like the content and you want more in the future. It really helps me and the YouTube channel out in a massive way. As we can see down here at the bottom, it has now downloaded the best model. We can just show it in the folder, and then we can just import this PT file here later on in our own Python script. So if you're interested in other tutorials about deep learning, computer vision, and so on, I'll link to one of my tutorials up here, or else I'll see you next video, guys. Bye for now.